guys, I just came back. You wouldn't believe this. I just came back from a conference in Washington about mathematics. It was a big honor. And I even saw the president there. So this is my break. I'll do this in a short time. So thank you guys. Okay, so I'll start off with Isaac Newton, then Euclid, then Blaise Pascal. Those are three mathematicians. My complex question was, how do these mathematicians contribute to the understanding of math? First, I'll start with Isaac Newton. I'll get my notes. Isaac Newton was an astronomer and philosopher. He made many theories, but one of his theories was about light. The main thing he took a lot of time on was calculus and geometry. And he also did motions for fluids. Newton's big contribution was for his three law of motions. More of Isaac Newton. Isaac Newton was influenced by Galileo Galilei because he also did astronomy. Isaac Newton contributed to the mathematics because his theory for gravity, what was also known as the apple that hit his head, was so much known that he became so famous. Now I'll talk about Newton's three law of motions. Newton's first law of motion was that if something goes in one direction, it will stay there, and it will keep on going in that direction unless something moves it. That was the first one. And here, that was over there, that picture. Newton's second law of motion is that the more force you put, the more acceleration comes. You might be scratching your heads and thinking, what in the world is that? That means that the more force you put on the mass, the faster it will go, the more acceleration. And that was over there. The third law of motion is that in every action there's a reaction. That means that every action, which is force, which is a reaction. Forces are found in pairs. For example, think about a rocket. If you blast off, there would be an action and a reaction. The action would be the accelerated air mass with fire or heated air pushing down, and the accelerated and the reaction would be the rocket being thrusted upward. What would happen if the sun disappeared? Have you ever wondered what would happen if the sun disappeared? Well, you're in luck. If the sun disappeared, the Earth's gravitational pull will stop. That because the sun its gravitational pull is on the Earth. So instead of orbiting, it will start going in a straight line. This is when Isaac Newton's first law of motion comes in place. It will start going in a straight line, then it won't stop at all unless something moves it, which I doubt will happen, unless Jupiter or Saturn comes in and smashes it into another place. But as I was saying, it will keep on going all the way to outer space, to the Kuiper belt and asteroid belt, which is way outer space. More of what happened if the sun disappeared. If the sun disappeared, then sadly we wouldn't exist, but the good part about that is that the Earth will freeze over time and we wouldn't have to suffer. So Isaac Newton did a lot on gravity. He was known for that. Now I'll talk about Euclid. Euclid contributed to the field of mathematics because he created Euclidean geometry. Euclidean geometry was the first form of Greek math translated into Arabic. Arabic and Latin later on. President Lincoln was fascinated about Euclidean geometry. Euclid was very much known for his Euclidean algorithms and his text elements. Euclid's text elements is an early organized treatment of this kind of geometry. This kind of geometry was based on axioms or postulates. This is the kind of geometry familiar to most pre-college students or later on high school. It's very hard for you to understand. So if you don't know what it is, it's okay. I'm with you guys. And now I'll tell you what axioms and postulates are. An axiom is, the definition of an axiom is to deem worthy, which is also named as self-evident. A postulate is the basic truth, or a much larger law, theory or law. That just basically means to assume. Euclid did a lot on geometry. He was actually known for geometry. Geometry is one of the oldest disciplines in mathematics. Geometry goes back to where Euclid is. Now I'll talk about Blaise Pascal. Blaise Pascal was another mathematician. He contributed to the field of mathematics because he was laying out the foundation of probability and statistics. He also worked on barometric pressure. He was the one who created the barometer. It's something that measures barometric pressure. Blaise Pascal created something called the Pascal's theory. I'll talk about that in a moment. This is what a barometer looks like not in Pascal's day, but kind of recent. And this is what probability and statistics look like pretty recent. So more of Blaise Pascal. So as I said, I'll talk about Pascal's theory. This is Pascal's theorem. This theorem said that a hexagon inside of a circle forms a line where the 3 points of opposite sides stay. This line is known as the Pascal's line. It goes through the hexagon. Another of Blaise Pascal's contributions was he was one of 2 people to develop and construct a working calculator. And that was really an honor for his time. So, like I said many times, Blaise Pascal did work in barometric pressure. What time is it? 12:40 already? I need to go to my presentation. I'm going to be late. The president's there. Bye.
That's pretty much right on 12:40.
Can I talk about visually?
Yes, please do.
Can I have a volunteer? Can you hold this? Yeah. Okay. So this thing represents a black hole, and that is Earth. That represents Earth. So this is a black hole, and this represents the sun. Okay. Can you make this spin around the sun? So this is the orbit around the sun, and this is the gravitational pull around the sun. But if the sun disappeared, then it would stop and start going in a straight line this way, and eventually either get sucked to a black hole or go into outer space. So that was my visual aid.